EG-121 Transport Engineering and Surveying, Video Lecture 3B, Coordinate Systems. Okay, so this week we've been looking at different reference systems for global coordinates. Now we either tend to use one of two. Spherical coordinates, in which case we're looking at degrees and distances, so latitude, longitude, degrees, or Cartesian coordinates, which would be distances in 3 dimensions. So let's consider 2 points. You've got origin O and point P, and we can describe the relationship and distance between them in 2 ways. Either using rectangular coordinates, so we define a north, we measure the change in distance east and the change in distance going north. We can give that information to someone to find P. Or alternatively, we can use the polar coordinates, and this is what is normally used in surveying because it is quicker and it allows you to take all the measurements from one point. In polar coordinates, we just need to measure the distance between the 2 points and also the whole circle bearing, which is the angle measured from north to that line. Let's look at an example of how this applies. We've got point A and we know the coordinates at this point. We know that they're 1,000 metres east and 1,500 metres north. We wish to know the coordinates of point B and also of point C. We don't know the coordinates, but what we can do is make some measurements and determine what they are using this polar system. Now, if we measure the distance between A and B, and we measure the whole circle bearing, that whole circle bearing is the angle from north round to that AB line, which is given as 130 degrees. We can put those values into the formula in the top right-hand corner. So the existing easting, which is 1,000, plus the distance between the 2 points multiplied by sine whole circle bearing AB. Similar equation for the northing, and we should come out with those 2 values. So the position of E is at 1229.813 metres east and 1307.164 metres north. We can just do a quick reality check and make sure that's right. If this is 1,000 metres east, we are further east, so we would expect that easting value to increase. And we are moving in a southerly direction, so that reading of metres north should decrease, and it does. And we can do the same for point C. Measure the distance. Measure the whole circle bearing, which is the angle clockwise from north to the AC line. And then the easting of C comes from the easting of A, 1,000, plus the distance, 400 multiplied by sine 100. The northing of C is then the original northing, 1,500, plus the distance, 400 multiplied by cos 100 degrees. It's worth pausing here for a second to look at those whole circle bearings in a little more detail. So we use the Greek symbol phi. To symbolise whole circle bearing. Sometimes it's referred to as a WCB, but it's all the same thing. Now, phi is not used in the same way that we use theta, alpha, beta, etc. to denote angles. Phi is always measured from north. So if I have a point A and a point B, as long as I know where north is, and I know which direction I'm moving in, so I'm moving from A to B, my whole circle bearing is measured from north, moving clockwise until I hit that line. So that's phi AB. If I wanted to measure phi BA, which is in the other direction, I always want to measure from north at my origin. So let me just put B on the other side so it's a bit neater. If I want to work out phi BA, I start at north, I go clockwise until I hit the line. Now you can see that for any given line, phi AB is going to be equal to phi BA plus 180 degrees, and vice versa. Good, so let's look at an example. Intersection examples, the method is very, very simple. You've got a formula, you need to know where 2 points are, you need to know what 2 angles are, and you plug them into the formula. And you've got all the information in this question here. So in this case, we need to determine the coordinates of an inaccessible point C. We've got the eastings and northings of 2 known points, and we've got internal angles CAB and ABC, and they are given. These are the formulas we use for intersection angle. And the steps are, we need to label the points clockwise, otherwise the method isn't going to work. Measuring those internal angles, which were given in this case, and then we apply the formula. Okay, so it's always a good idea to, rather than just blindly follow all the data and put the numbers into the formula, now I would always plot it out. And if you look at the respective locations of A and B in terms of their eastings and northings, the relationship to each other is something like this. So B is to the east and to the south of A. We know that for intersection examples, point C is going to be on this side. How do I know that? I don't know exactly where it is, I'm just drawing it in. Well, we know that in intersection we have to label the points clockwise. So A, B, C, this is a clockwise labelling system. If C was on the other side, it would be anti-clockwise, it wouldn't work. Okay, let's go back to the black pen for A, and let's write those coordinates on. We've got 1309.12 and 1170.50, and the coordinates of B are 1525.43, 958.89. I've also got those angles, which I could draw on here. So the angles I've got here are CAB and ABC. So angle CAB is 85:38:49 seconds, and angle ABC is 55:50:53. Now when I apply the formula, we have to express this in cot, so it's a good idea to write these out. So cot of the angle CAB is equal to 1/tan of CAB, and likewise for ABC. So I can put that into my calculator. 1 divided by tan, 85 degrees, 38 minutes, 49 seconds. 0.0761. Actually, I'm going to write it in is equal to 0 degrees, 4 minutes, 34 seconds. I could do the same with cot of ABC. which is 1 over tan ABC. So 1 over tan, 55 degrees, 15 minutes, 53 seconds. And that's 0 degrees. 40 minutes, 42 seconds. Right, now's the time to put it into the formula. I'm going to read it off the screen, I'm not going to write it out in full. So the easting of point C, so the eastern coordinate of point C here, is equal to the easting of A, which is 1309.12, multiplied by cot ABC, add that to the easting of B, which is 1525.43, multiplied by cot of angle CAB, subtract the northing of A, 1170.5, add the northing of B, 958.89. All of that is over cot A plus cot B. Put that into the calculator or into MATLAB or whatever you're using. And we come out with an easting value of 1050.45 meters east. Do the same for the northing. Put all the values in. So the northing of A, 1170.50 multiplied by cot B, 0.4042, plus the northing of B, times the cot of A, plus the easting of A, minus the easting of B. All divided by cot of A and cot of B. And for the northing of B, we get 863.07 meters north. We then finish off the question and say coordinates of C are 1050.45, 863.07. Now you also need to make sure that you can calculate resection. Again, it's a fairly trivial mathematical process. There's nothing difficult in there. It's just about following steps. So make sure you do all of the following. Any known points, if you're given 3 known points, label them clockwise. It will not work if you don't do them clockwise. Imagine that you set an instrument at your new position, so in this case it's the red location, and you're able to measure the internal angles sighting to all of those points. So those angles, you need 2, and then you can use those to work out the third one, because they will all sum to 360 degrees. Use the known coordinates, that's EA, NA, EB, NB, and EC, NC, to mathematically calculate the distances between those three known points, AB, BC, CA. Use the cosine and the sine rules to calculate angles A, B, and C. And apply the Teenstra formula. And then that really is all there is to it. So have a look at the example I went through in the lecture notes. All the steps are here. You can follow them if you need to. It doesn't matter whether your new point P is in the middle of those three known points or it's outside of those three known points. The procedure is identical, it's exactly the same. You should now be able to do all the exercises in exercise sheet 3. When you're faced with the questions, have a look and see what information you've got. If you've got two known points and you know that you can take measurements from the new point, then you can use the angle and distance time method. If you can't occupy the new point, you can use the intersection time method, and if you've got three known points and you can occupy the new point you're trying to find, you can use the resection method. If you get stuck, the best thing to do is plot out the information, plot out where your known points are, and have a think about how all the points relate to each other, and that will normally lead you to the method or solution that you need.